Alright, so in the last lesson we learned how to graph something like y equals cosine of x. In this lesson we are expanding our knowledge and figuring out how to graph a sine or cosine function when there's a number in front, which is going to affect the amplitude or height of the graph. And then if a number is being added out front or out back, which is going to give it a vertical shift. So we're talking about amplitude and vertical shift. So the bottom line is this, and hopefully this looks pretty familiar because we talked about this with parabolas and graphs of other functions like the logs and exponentials and whatever. So a coefficient, a number out front, affects the amplitude, and in our basic sine-cosine graphs, this was always 1. And remember how the largest value was always 1 and the smallest value was always -1. So essentially this number, whatever it is going to be the height, the biggest and the smallest value of the graph. So we will see some examples down below. A number that is being added or subtracted, so not multiplied with the cosine or sine term, is going to be a vertical shift. So hopefully that term sounds familiar, but basically what it means is we're going to move the graph up or down. So let's say move up or down. And if it's being added, that's going to be up, and a subtraction would be down. And let's put a little arrow pointing this over to this, so that we know what's up. Alright, so that's all we need to know. Easier said than done. Let us practice. So, first example we have y equals 2 cosine x. And when you're graphing these, if you're completely struggling, you may want to just go old school and create a table of xy values and plot points, and then make a smooth flowing sinusoidal graph through them. That will always work. Okay, it is a lot of work, but it will always work. So, where were we? We were looking at y equals 2 cosine x. Aha! So, this is our new amplitude, meaning, let's talk about points. Like when the angle is 0, we know that the cosine of 0 is, and you're thinking about the unit circle, and you go, oh, I know that, it's 1, okay? But we're multiplying it by 2, so it would actually be 2. So if you put 0, if you plugged in 0, you'd get cosine of 0 is 1, and 2 times 1 is 2. So if we look at the graph, y equals, so let's not forget about what our equation is, y equals 2 cosine x, okay. And we'll forget about the negative values for now. So here we are with y equals 2 cosine of x. And our standard values on the x-axis are, we have 1/2 pi, pi, 3/2 pi, 2 pi, and then we could continue with another 1/2 pi, so 5/2 pi. Alright, and our normal cosine graph would start at 1 and would be like this. So I'm actually gonna draw that. So if you don't know how this is working and you're like, now why did that? Oh yeah, that's correct. So here's our normal cosine graph. If you don't know how to do this, you should back on up and take a look at week 21, part 1. So this is y equals 1 cosine of x, and we have 2 cosine of x. It basically, from the x-axis, it stretches everything that way, and that way, and that way. So this is like we saw with parabolas, and it'll go up to 2, back down to 0, 0 times 2 is 0, and up to 2. So we have these values of 1 and 2, and then da-da-da. So let's label this, because this value here and we're going to use a thick marker. This value right here we call the amplitude. And it's just positive too. I know that the graph goes down below the x-axis here, but it's just the, like the absolute value or the magnitude, the amount of that distance. And amplitude. Okay, so our amplitude would be 2. That is the number in front of the graph, the number in front of the cosine or sine. And our function, the graph of our function, is like so. So again, we're learning how to be efficient with our time. You could plot a bunch of points. That would be a lot of work. Or we can use what we know about the basic graph and then just modify it. So there's our graph. Pat ourselves on the back and move on. Okay, so next up, y equals 3 sine x. We know that our amplitude will be 3. Amplitude equals 3. And I'm going to kind of rush, well, not rush, but we're going to talk about sine of x. And so we have, hey, where's my marker? We have pi, 2 pi, 3 pi, and I'm kind of abbreviating. We know that, I'm going to put some detail in here. We got pi over 2, 3 halves pi, 5 halves pi. And when we're talking about the sine, let's see, sine of x starts at 0 and then 1. So when I'm graphing these, I think about the unit circle. You could memorize the graphs, but it's all, in my opinion, it's always better if you can just kind of figure it out, because then you're never going to forget. But if you memorize something, it's easy to forget that. Okay, so here is the basic y equals sine of x graph. However, our amplitude is our amplitude is 3, for y equals 3 sine x. So it's the entire graph has been stretched, I didn't say shifted, stretched by a factor of 3, vertical stretch by a factor of 3. Alright, so this would be up here at 3 and -3 and so on. Okay, so y equals 3 sine x. The amplitude has been changed. Imagine hands stretching. Here are hands, right? Stretching the graph like that. Okay. Next up, curveball. So y equals -4 cosine x. So pretend you're not looking at the negative. We're looking at the 4. We know our amplitude of the normal cosine graph is going to be 4. But there's this minus in front. And if you remember from not too long ago, so first let's get this down. Amplitude is 4. If there's a negative out front, that is a, yes, you guessed it, reflection across or about or in, sometimes we say, x-axis. Right, so it's like the rotisserie. It's going to spin around here. So let's see how that goes. And we're going to just kind of forget about the negative values for now. Look at the positive values. It's a little easier to think about. So, standard cosine graph. Whoa, easy there, T gray. That is not what I said. Pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. Okay, so basic cosine graph. At 0, when the angle is 0, cosine is 1. And then and Alright, so this is basic y equals cosine of x. And you don't have to draw each of these steps, but I am doing this because I hope it will help you learn. So let's see what happens now. Alright, and then we have 4. So 1, 2, 3, 4. Okay, So our new amplitude, so it's going to get a little messy, but we can take it. All right, so that was y equals 4 cosine of x. And then if we have this negative in front, it's basically taking this and rotating it around the x-axis. So in our beautiful orange, all the points get flipped. Yep, like this. And we'll go big fat marker for this. All right. These are kind of fun. So y equals negative 4 cosine of x. And that's how it looks. And you know, as you're going through this, you might want to be pausing and taking a look at Desmos. And you know, Desmos is not something that we can rely on, like, hey, I just type it in and I don't have to know anything. But it definitely helps with us visualizing these things. So this is how this graph would look. Let us proceed. Alright, 11 minutes, almost running out of time. So, alright. So we have 2 cosine x plus 1, so a vertical shift. So what I like to do is 2 cosine x plus 1. Because everything has been shifted up by 1, I will draw a dotted line that goes through y equals 1. So that's my new center. And I know that the graph is going to be centered around it and do, you know, something like that or like this or however it goes. But this is our new center. We can forget about that. We know that, at least for now, these are the values we're using. Right, we're splitting that 2 pi up into fourths. 5 pi over 2. Okay. So we're now graphing 2 cosine of x. Cosine starts at, so when the angle is 0, it starts 1. So the normal cosine graph, maybe I will show you this. The normal cosine graph would be like this. Whoa, okay, getting sloppy here. Alright, so this would be y equals cosine x plus 1, where that one is not in parentheses. So it's a normal cosine graph that would be like this, and it's just been shifted up by 1. Now let's see. Why is this looks wrong? Oh, Torville. Am I going to have to start over? No, I'm not starting over. Alright. I bunched it up here. It would be like this and like this. Oh, so messy. My apologies. Okay, so this is y equals cosine x plus 1. And here's a little, if you don't want to make this mistake that I made, you kind of plot the few points and then connect them with the graph. I got ambitious and made it too scrunched up here. So it's going to be like that, except the amplitude is going to be 2 instead of 1. So there's an amplitude of 1, amplitude of 1. So we would have something like this. So up to 2 above our middle, 2 below our middle, back to our middle, 2 above our middle, back to the middle, 2 below the middle, and so on and so on. So this is y equals 2 cosine of x and plus 1. And that could also be written like this, 1 plus 2 cosine of x. It's just 1 being added afterwards or beforewards, if that's a word. Alright, 3 plus sine of x. So we have our 3 plus sine of x. Ooh. So here's our new center, and we got pi over 2 pi, 3 pi over 2, 2 pi, 3 pi, and sine of x at an angle of 0. So So at an angle of 0, let's see, sine of x is 0. So it would be here at our middle, and then 1 above, and then middle, and 1 below, and middle, and 1 above, and middle. Let me see, does that make sense? Good, yeah, I didn't mess up. So our nice looking graph, it's the normal sine y equals sine of x. However, it has been shifted up by 3. Alright, so I hope that I don't get cut off. We're just past the 15-minute mark. So let's proceed and hope. And hopefully you're not bored to death. No, definitely not. Alright, so this has been shifted up by 2 and has an amplitude of 4. So we're going to draw our middle here at 2, and sometimes this is helpful. Alright, from 2, we know we're going to go up 4. So 1, 2, 3, 4. And you might even draw another dotted line. So that's going to be the top of our sinusoidal, the curve graph. And then from the middle, we're going to go, so here's our middle. From the middle, we're going to go down 1, 2, 3, 4. And we might, okay, so now we know sine or cosine graph or whatever, it's going to be like that, right? Touch the top, touch the bottom, etc. So pi, 2 pi, etc. If I have more time, I'd be filling in all these values, lots of detail. This is cosine, and so the graph of cosine at the angle 0 starts at its maximum value. So we have maximum value, we have middle value at pi over 2, that's our 0, our middle value, and then at pi it's our negative maximum, 3 pi over 2, our 0, our middle, 2 pi back to our positive maximum, 5 halves pi, 0, and 3 pi back to our negative maximum. Whew. So, nice, smooth, sinusoidal curve, like that. So I like this as a strategy. We draw our middle, we draw our maximum, we draw our minimum, we know the values, we plot a couple points, and then we can avoid that mistake I made previously of just kind of randomly drawing some squiggle and hoping it's correct. No way. Alright, so what do we have here? Aha, our middle is going to be down 2, so I kind of set the axes up that way. And then we'll go up and down 3 from negative 2, our new middle point. So negative 2, there's our middle. And we're going to go up 3. So 1, 2, 3. Here's our maximum. And down 3, here's our minimum. And let's see, what are our values? We got pi over 2, pi, 3 pi over 2, 2 pi, 3 pi, etc. And the only question now is, are we graphing sine or cosine? Ah, it's a cosine. So we know that our cosine at an angle of 0 starts at maximum, and it'll be maximum, middle, minimum, middle, maximum, and so on. Maximum, pi over 2, because cosine is 0. And again, if you're like, where on earth is he getting these points? I think you should do this. Alright? And, well, that continues. Actually, wait, we can do that. So this continues, and you would be putting in pi over 2, pi. 3 pi over 2, 2 pi. And you can plug those values in. And you know, do this. If it's confusing, do that, all right? And it's going to take more time, but know that this is going to help you understand what I'm doing. So you'd be doing that, and you'd be plotting the point. At pi over 2, the value you'd get would be negative 2, and that's where this point is. Okay, so these will be like this, and our cosine graph will look like that. Okay, so I know that's a lot of information, but you definitely have some practice, and we are dealing with amplitude and vertical shift.